Oh, you know what? Because I'm going to show you this anyway. So don't get me wrong, right? Some people are able to memorize the chart as is. You know, I think this is called photographic memory, right? If you don't have that, anyone does? then do it in the right way. Don't memorize the chart like that. All right, so what you should do is once you get the test packet and the spreadsheet from me in a test, go ahead quickly draw these two triangles. Right? That's 30 degree, that's 60, right? So the opposite of 30 is always 1 unit. Hypotenuse is always 2 units, right? And the adjacent of 30 is always radical 3. And that 45 degree. Right? The two sides are 1, hypotenuse radical 2. And use these two triangles to figure it out all 6 functions. But, I mean, the basic ones are sine, cosine, tangent, right? And the remaining 3 are the reciprocals. So do that at the beginning of the test because you probably end up using it, you know, throughout the test. Okay. But again, you know, you figure it out however you can do it. But like I said, since you're not allowed to have a cheat sheet, this is not the only thing you have to memorize. And one of the students asked if I could put, you know, all the identities and conclusions that I think that you better remember, you know, and provide you guys that kind of a sheet before the test. You guys can just go ahead and memorize them. So I'll try to do that maybe later today or tomorrow. I'll send it to you. Then if you're super bored in the weekend, then you can do it, right? Just memorize them. But the thing is, if you have a sheet like that, bring it to the date of the test and memorize these things as much as you can for however many times you can before the test, because your memory is going to work out within 5 to 10 minutes. And again, once you receive the packet, write them down, right? So even though that you spend probably 5 minutes, write down all the formulas, but that's going to save you tons of time, right, later on. And that's legal, right? Because whatever in your head, you're able to reproduce it during the test, that's yours, right? All right. Now today we're going to try to finish, you know, 5.3, and my goal was even get started with 5.4. We didn't have to because I was, you know, not slow at all. But now I kind of have to rush just a little bit. But I was told that 5.4, and double checked, it was the case. That 5.4 is a lot shorter than normal. So it's possible that you know, if we just finish 5.4 on Monday, then Tuesday when you come back, you know, we'll do you know, as many test review problems in class. You guys try and, you know, figure it out. And I hope that I'll have you that kind of a cheat sheet by Monday, right? You're gonna start, well, not by Monday, by tomorrow, right? You guys are gonna start memorizing things and even print it out or have it on your phone and have it, you know, on the side, right? When you practice those problems, and later on you know, naturally memorizing these things. So now we need to deal with something called reference angle, which is the last thing we have to do for 5.3. So what's reference angle? And let me show you the definition. Well, once you understand how the reference angle is defined, then later when you have to calculate the reference angle, it will be you know, surprisingly easy. But then the definition might be a little bit, you know, too abstract. That's why they provide you, you know, those you know, figures. The reference angle is always a positive and acute angle. So an angle that's less than 90 degrees. And that angle is made by the terminal side of an angle in a horizontal line in the coordinate system. That's why they didn't show you what happened when the terminal side in the first quadrant. Because there's nothing you have to worry about a first quadrant angle because it is acute. So whatever you know about right angle trigs applies to a first quadrant angle. Okay, SOHCAHTOA. Right? But when an angle is in a second quadrant, the terminal side in the second quadrant, you need to find an angle that's made by this terminal side and the horizontal axis, which is just that little angle here, right? It is less than 90, right? And it's positive. We're going to call it theta prime. Right? So that little apostrophe is, just a notation, right? So theta prime, so then you know that it gotta have to do something with the theta. But how much is theta prime? If the big angle here, theta, is let's say 150 degrees. Okay, so you can tell right away, right? This reference angle is 30 degrees. Yes. So it's very straightforward. Now, what if it's in the third quadrant? Let's think about maybe this big angle all the way to the third quadrant is, let's say maybe 240 degrees. So what do you think will be the angle made by this terminal side in the horizontal line? So it will be the difference between 240 and 180, right? Which is 60 degrees. Yeah. I think that you start to realize, oh, that's not too crazy, right? It's just the angle between the angle that you don't want to deal with, like 150, 240, which is kind of too big, and 180, right? So you can get a small acute angle, right? Now, the last one, when the angle is even bigger, right? So it's not ends up being in the fourth quadrant. So this big angle here, theta, let's say maybe it's 330 degrees. How much do you think will be its reference angle? The angle between the terminal side and the horizontal axis, yeah, that will be 30 again, right? Okay, so now I hope you realize, once you understand, oh, it's just the angle that's in between a terminal side and a horizontal line, and the angle needs to be small and positive, you don't need to memorize these formulas. Like, oh, it's the second quadrant, you subtract that angle from 180, or if it's greater than 180 in a third quadrant, you subtract 180 from that angle, or subtract the angle from 360. Okay, so it's all about you finding the difference of an angle that you don't want to deal with in 180, okay, or 360. Let's try it. Stop thinking about those complicated, situations. Your goal is to find a small positive acute angle, but you're given an angle that's too big. All right, you're trying to find the difference between that big angle and 180 or 360. That's going to get you a small acute angle. All right. Well, let's try. Now, can you guys pretend not seeing the diagrams up there? So an angle, let's say 135 degrees. Let's just think how I'm going to get an angle that's small, positive, and acute. It needs to be the difference between that angle and either 360 or 180. Okay, you see that it's close to 180, right? So now how about we go ahead and subtract. So 135 subtract 180 just to make it smaller, because that my goal is to get a small acute angle, right? But unfortunately, I overdid it, right? So I get negative 45. Is that my reference angle? No, by definition, reference angle needs to be positive. But guess what? The reference angle is nothing but the absolute value. So you just take 45 degrees. Isn't that easier? Because all you have to think is what you want to get and what you don't have, and just try to, make it work, right? But it does make sense now if you go back to the diagram out there, and let's see if it's really the case. Do you see that it doesn't make that much difference? When the angle is less than 180, you subtract that from 180. When it's greater than 180, you subtract the angle from 180. You are just finding the difference between that angle and 180, right? If you overdid it, I know the difference 45, take the absolute value. Because your goal is to get a positive acute angle, right? When your angle is small and close to an angle you want, just forget about the negative sign, okay? Now, hold that thought. And again, let's use not just those complicated situations, right? Just by thinking about what you can do to get yourself a reference angle, right? So say in letter A, don't draw it. You could, but think through the process. I have a 210, right? So I'm finding the difference between this guy and 180, right? So this guy's big. So how about I just go ahead and subtract 180 from it? 210 minus 180. So you get what, 30 degrees, right? Is that what you want? That's it, right? Go ahead and say that this is your reference angle. Okay. Nothing too crazy, right? Okay, now I guess that people's gonna, struggle a little bit with the radians, right? The only difference is that you cannot play with 180 and 360 anymore. It has to be either pi or 2 pi. Now, first off, I realized that the angle theta is 7 pi over 4. It's obviously too big, right? How would you make the angle smaller so that it will be an acute angle? Okay. Do it again. Minus 2 pi. Okay. Now, let's pretend that we didn't know that 2 pi is a much smarter choice. But you're right, right? So we'll get to that. So let's say I feel like that. You know what? Let me just go ahead and subtract pi. See what happens. Just like I did to the degrees, right? So let's say, hey, I will subtract a pi. Now, how much is it? If you want to keep that in a fractional form and also the pi, am I just subtracting 7/4 and a 1? Right? 1 is 4/4. You get 3/4 pi. So now you're thinking, okay, am I getting the reference angle? Hopefully it's small enough. But unfortunately, it's not small, right? How do I know it's not small? By small, I mean it needs to be less than 90 degrees. But you're not comparing with 90 because you don't have a degree here, right? So you compare that with pi over 2 or half pi, right? 3/4 pi is obviously greater than half pi, right? So that is still some room for you to make it smaller, right? So now you know what? That's the first round. I'll do another round of subtraction of a pi. So now, I mean, unfortunately, I overdid it, right? Because it's going to be negative 1/3 pi. But you might say, what's the big deal? 1/3 pi is small, right? It's, 60 degrees. So you know what? The reference angle will be absolute value of 1/3 pi. Absolute because, we want a small positive acute angle, right? So that will be pi over 3. Yes, Anani? Say it again. Why is that 3/4? Because that's greater than 90 degrees, but we want acute angle. So now, you guys remember, just Juan says, why don't you just subtract 2 pi in the first place? Yeah, we should have done that. Do you see that? But I don't know, because if I haven't tried it, how will I be smart enough to figure it out that, I end up subtracting pi 2 times in a row? But that's the experience you get, right? So it's okay that you're gonna do it one step at a time, because you want to make sure that some of the process that's easier for you to remember. How would you make it easier to remember? It makes sense. What makes sense is the angles is bigger than 90. You can keep on subtracting 180 until you get something that's close to 90, right? But if you overdid it, take the absolute value, okay? But later on, if you realize that, oh, you know what? This guy is closer to 2 pi than it is to pi. Do you guys realize that? Because 7/4, 2 pi, 2 pi, you can write it as a/4. 7/4, a/4, they're so close to each other, right? You could have just subtract that guy from a/4 pi, and you're gonna get pi. Oof. No one remind me that I did a math error. I'm sorry. I'm sorry. Hey. So this is why, if you guys feel like that, you don't like the radians, me neither. It's just so hard to, keep from that, anyway, so yeah, it's 1/4 pi. Right. Anyway, yeah, go ahead. Well, that's a good question. You'll see that, in a few minutes, right? But you will probably like the reference angle once you realize how much you can get out of it. But you first have to get it right, right? Now, why don't you guys try letter C and D? Why don't you? Right? Why not? Letter D is 3.6 radians, just so you know. That's a period. I know, yeah. What is it? Letter C, yeah. And the way you can tell whether you did it right is ask yourself, did you get a positive acute angle? Right? If it's positive, if it's less than 90, then you're right. But what if it's radians? Then you make sure that it's less than pi over 2, right? But pi over 2, pi is 3.14. Pi over 2 is 1.57. If you get a decimal, which is in radians, less than 1.57, you're good. Right? That's the way to tell. Yeah. Yeah.
The formula you thought is not. It's like nothing is getting canceled now.
Right. Now, don't do that. Well, you could, but then you're gonna get yourself even ugly numbers. So, if we're gonna be keep on subtracting pi, why don't you just keep it like that? But you do have to put 3.14 instead of pi, right? Mm-hmm. And that will be in radians. All right, just one more minute, finish up the work, because I think that most of you will just have to think a little bit longer for letter D. But once you see how it works, then don't let the superficial stuff to bother you. Just because it's radians, right? Just because it's harder to think what radians is. Don't forget that you're still doing the same thing, right? Because math is not about you learning how to solve a particular problem, right? It's about how you know to solve a problem in general. You're learning the method. Right. So I guess it's good enough, right? So you try it, you see that something that works out pretty well, like letter C, right? Letter D, maybe there's some hiccup, right? In letter D. Anyway, so letter C. Please think for one more second before you try those, like add or subtract 180, 360. We have a negative angle, right? What will be the first thing you do if you see a negative angle? Add something, right? But just to be safe, not really that smart sometimes, but at least just want to be safe. So if I were you, I'll add 360. Because that's the safest things you can do, right? When you add or subtract 360, it will never get wrong. So you get positive 120. Okay, so but now I realize, oh, it's still too big, right? So what I'm going to do is I'm going to subtract 180 to make it smaller, but I overdid it, right? I get negative 60, right? But then you realize, okay, I'm going to take positive 60 as the reference angle, okay? But I know that some of you don't like it because I saw that people did it, much quicker. So the reason why I'm showing you this, let's say if you forgot the reference angle, the quickest way, right? So you want to be safe because you want to first get the question right, right? So like my son, he's trying to get the things quickly done. And I said, well, if you don't get it right, what's the point of getting quick? So I said, well, you know what? I don't like negative angles. Let me first make it positive. Isn't 120 at least a little bit better than negative 240, right? So now I'm thinking of 120. Oh, that's easy, right? So you see right away the difference between 180 and 120 is 60, right? But if you're like, someone who realized, you know what? If I just go ahead and add up, negative 240 and a 180, I'm getting what? Negative 60 right away, right? And I realize I want a small angle, and I do get a small angle. It's negative, just go ahead and take that as value, right? So that'll be a lot quicker, but guess what? Most likely you're not going to realize you could have done that without trying it first, right? So this is probably a little bit stupid, but safe way. Then later you come up with a smarter way. Yeah. You could do that and you get the same answer. So now you see that you might word it a little bit differently, and you might get 60, negative 60 in a slightly different order, right? But remember that our goal is the same. We want to get 60, a positive acute angle. However you get there, it's fine. But of course, you're trying different ways, and later you find the quickest way. All right, so now let's see letter D. A lot of people, I remember from the first two periods, try to convert 3.6 radians to degrees because they're now getting used to use degrees. I mean, you could do that, but do not waste your time doing it. So just like you're saying, or just now someone said, well, can't you just find the difference between 240 and 180? Right? I mean, can't we just do that with the pi? Pi is a different way of saying 180, right? So now, first off, is 3.6 greater than 2 pi? Just want to make sure if it's greater than 2 pi, you better, make it smaller. Pi is 3.14. 2 pi is 6.28. So 3.6 is less than 2 pi. So you're good, right? It's just still a little bit too big. So I'm going to subtract pi, which is 3.14. You get 0.46 in radians. So now, do we stop or we keep on going? Because 0.46 radians is less than pi over 2, right? So you're good. That is a reference angle, right? Positive acute. All right. Now, let's make things even more challenging. Number 6. Why not? Number 6. So now you're looking at an angle that's greater than 360. 660. Okay, good. You subtract 360 from it, right? Put it small, and you're getting. So let me write it down. All right. So. All right, so first I'm going to be looking at, instead of 665, I'll subtract 360 from it. I'm getting 305. All right, so it's a big angle, right? But not insanely big. So I hope you guys see right away, it's so close to 360, right? The difference is going to be 55, right? Isn't 55 the reference angle? Yes. But you know what? The stupid way to do that is, let's say if I put out I didn't know it. So I say 305, that's kind of big. Let's go ahead and subtract 180. Let's see what happens. When I did it in the calculator, I'm still seeing a big angle. I'm going to do it again, I'm going to be getting a negative angle. But guess what? Negative angle, I take it positive, right? But then you realize, come on, it's so close to 360, right? The difference 55. There you go, right? Now, but letter C, I want you guys to try it. I mean, I think that letter C is even harder, right? Let's do the letter C. It's negative and it's big, right? It's a super negative angle. What again?
Wait, that's clearly not right.
Yeah. Sure. See. Yeah. Yes. 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 Yes.
Not quite.
That's.
Getting it.
But where's the pi?
That's fine. 3.14.
Oh, that's multiplying.
That's subtraction. Why would you add the pi?
Oh, the pi is multiplying with the 11 over 3.
Oh, I forgot to do that. Oh, no way. I have this pen.
All right, one more minute, then we'll go over that. And I think that if you can handle 6C, then I don't think you're gonna have any issues with reference angles. All right. All right. So if you already have the answer, the reference angle is pi over 3. All right. So let's see how that works. First off, you guys realize it's a negative angle, right? So let's just go ahead and keep on adding 2 pi to make it positive, right? And let's see what happens. Maybe somewhere along the way you'll get something that you like, right? So let's say negative 11 pi over 3, right? I'll add 2 pi. I'll try to keep the fractions. So negative 11 over 3 plus 2, right? I'll pull the pi out. So that's going to give me, so 2 is 6 over 3, right? So this is nothing but 11 over 3 plus 6 over 3. All right, so I'm going to get negative 5 over 3. Well, still negative. That means I need to do more, right? So negative 5 over 3 pi plus another 2 pi. All right, so that's negative 5 over 3 plus, now I'm going to do the same trick. 2 is 6 over 3. Right? So now what I'm getting is, what is that? Pi over 3? Okay, wait. Isn't that what I want? A positive acute angle, right? But do you realize what's happening here? We didn't really follow exactly the same strategy of finding the reference angle. Because I said you're trying to find the difference between an angle and the 180 or 360, right? Just keep on subtracting the 180. But what do you think we're trying to do by adding 2 pi to a negative angle? Well, this is not a reference angle, but it's called coterminal angle. Remember that coterminal angle is equivalent to the angle you start with, right? And just by adding, subtracting 2 pi or adding, subtracting 360, it's always safe to do it. So that's why we didn't realize that as we trying to get the angle to be more and more positive, less and less negative, I added 2 pi to get this coterminal angle, but it's still negative. And do it again. It's just so happened that in this case, as we're getting a coterminal angle, we thought we're going to have to do more to get a reference angle, but it's already a reference angle because it's already positive acute, right? Like I said, for some tricky questions, don't forget that you're going to stick to the plan, right? If the angle is negative, keep adding it to make it positive. Maybe that's all you have to do, right? But if not, I mean, you see what happened, right? With negative 240, added 360, it's too big, let's start subtracting, right? Because my goal is to get a small, positive acute angle. So now I need to, yeah, go ahead. Negative 9 over 3, negative 3 pi. Oh, you're not supposed to add the 2 directly to the 11 or negative 11. You have to make it the common denominator. Yeah. All right. Now I think that there was a question just now, like, what's the whole point of finding the reference angle, right? Well, you know what? This is what you can do, or how you're going to be using the reference angle, right? So they say, if you have a trig function evaluated at an angle that you didn't like, it's either because it's big or negative. When I say big, it's greater than 90. You could replace this angle with its reference angle. Now, who can tell me the reference angle of 135? 45. See that for easy ones, you guys can just quickly do mental math, right? And that's why you're going through the hard ones. But here's the catch. You don't know whether it's positive or negative right off the bat. That's the price you pay. So reference angle is nice because it gets you the value of the function of an angle that you don't like, but at least it comes with a price. The price is you might have to deal with a negative. But it's easy to tell how to figure out a negative sign or positive negative. Ask yourself, in which quadrant do you think that 135 degree is in? Second quadrant, right? Is sine of a second quadrant angle positive or negative? A smart trick class, right? So it is positive. And that's why you're getting that quadrant thing. So now you can use that along with the reference angle to figure it out. A trig function, if I were to add an ugly angle, right? You just have to figure it out. The reference angle first, then the sine. But it could be negative, right? So now let's go ahead and try something less trivial than the example I just showed you. Sure. This one, right? Oh yeah, the definition. Okay, yeah. Go ahead. It's recorded just in case if I didn't get back to the things you want. All right, so now let's take a look at 7a. So I want to figure out what sine 300 is. But the theta is too big, right? So let's go ahead and find out what the reference angle is. But that's not too hard, right? So what should be the reference angle for 300? 60. Okay, so now we claim sine 300 is pretty much sine 60. But is it going to be plus or minus? That depends on whether sine of 300 should be positive or negative. But 300 degree is in quadrant 4. Quadrant 4, cosine is positive, but sine is negative. Right? A smart trick class, right? So that's why you're going to go with negative. See how that figured out the negative sign? Right? Go with the quadrant. Okay. You know what? I'll skip letter B. You know that seems scary, but it's not. Let's go to letter C. I know you guys like secant. All right. So now what are we looking at? The angle is negative pi over 6. What is the angle? What is the reference angle of negative pi over 6? Think hard. Try not to do some kind of a over. So would you say that would just be pi over 6? Now, the reason why it is, remember there was a problem that we keep adding to make a positive and keep subtracting and we get a negative angle somewhere along the way. And we say that, oh, I overdid it. So it was negative pi over 3. I take that as the value, right? This could be an angle that you were adding, subtracting, and you somehow get an angle which is already small and it's close to 90. The only thing that bothers you is negative sign. Throw that away because I don't care negative sign because I want a positive acute angle. It's already acute angle. It's just negative. So it might be surprisingly easy, right, if you really understand what you're trying to get. So I claim this is the same thing as secant pi over 6. But the question is, which sign should I go with? So now I have to think, in which quadrant do you think that negative pi over 6 is in? It's a negative angle. It's going to turn clockwise, right? But pi over 6 is a small angle, right? It's going to go down a little bit, right? It's a fourth quadrant. So now it's secant positive or negative in the fourth quadrant. Because cosine is positive, it's reciprocal. That's why it's positive. Now, but still we're not done yet, right? So I don't know what secant pi over 6 is. So let's go ahead and draw that special triangle. As you know that pi over 6 is 30 degree. You have a 30 degree, 60 degree, right? The opposite side of a 30 is 1. This is 2. That's radical 3, right? So now you know what? If you don't like secant, it is the reciprocal of cosine right? So cosine pi over 6, cosine 30 is adjacent to the hypotenuse. So you're looking at radical 3 over 2, but you're flipping it, you get 2 over radical 3, right? It's not wrong if you leave it like that. But if you could, rationalize the denominator just in case. There you go, right? But I'm going to highlight the sine because that's probably the only thing that you're going to have to seriously take, take care of. Because now you see that it's not very often that you're getting those like super complicated angle, like a negative 11 pi over 3, right? So for a lot of the reference angles, they are a lot easier than you thought to figure it out. And you might even just take an educated guess, like you guys probably did, for negative pi over 6, right? Do that. It won't hurt. Because now you know how to check, right? Because, it's like when we do the stupid ways, because we don't know if it's going to be right or not. So that's why we want to be safe. But now, let's say in SAT, or if you see that, well, you know what? That got to be the answer. For some reason, I just feel like that letter A just seems right. And you know how to check it, right? And that's probably the quickest way, right?